Hello, everyone. Welcome to ITS450. ITS450. All right, so let's get started.
Professor.
Everyone.
Professor, this is 450.
Oh, I'm sorry. sorry. You guys are my last class today, and today is a very busy day, so forgive me if I say crazy things sometimes. All right, apologize. Yes, welcome to 450, Software Assurance. Okay, so 450, there we go. All right, so a couple of things. One thing, the first reminder is we have our exam on Tuesday. Okay, so we have our exam on Tuesday at this time from 6 to 7:40, right? This is your written exam. It's gonna be online somehow, right? And there's gonna be some questions there. So about 10 questions or problems, pretty much the entire sequence from set UID, memory and format string, all the way to the secret key, sorry, to the, not secret key, to the buffer overflow lab, okay? So please make sure that you study for that, okay? The other thing I want to address today is I've graded your set UID lab. I graded set UID, right? And you know, it was kind of mixed. So half of you did really well, and then half of you not so well. So I want to stress again that lab. Now I am willing to give you, for those of you that got it wrong, I am willing to give you a second chance to submit it, but you got to do it right. Okay, so I will only, you know, I will only accept when, you know, the solution if you've done it correctly. I really, for that lab, there's only one thing that I really care about, okay? And that is the, that you read that secret file correctly, because I want you to understand something. So today, I'm going to once again go over that, all right? I'm gonna try to give you the sequence of steps even, but I need you to understand this concept, okay? I need you to understand this concept a little bit better. All right, so we're gonna do that. So I'm gonna go back to set UID today. And then after that, you know, given that we're getting close to the exam and I really need to make sure you're understanding everything, I'm gonna again do this lab, kind of an open lab, to iron out some questions. So I've noticed in buffer overflow is the same thing. Half of you, you know, got it. Half of you are still working on it. So make sure you ask questions. Now, at least I think the set UID lab is actually very short, but I agree that it's always a little bit confusing to understand if you were successful or not, because it's not very obvious. At least with buffer overflow, it's a harder lab to be successful in, but at the same time, it is very obvious, right? So you understand really clearly what you have done. So anyway, so let's, so again, I remind you, exam on Tuesday, and then don't forget that written exam online. So all you have to do is, you know, come into the Zoom session at 6, and I will be here, and I'll just say, okay, your exam is on, and I might give you a few short instructions, and then you can start working. All right, so before I go into set UID again, are there any questions?
No, not right now.
All right, no questions. All right, so set UID. I really, the main thing, you know, everything, as I said, I don't always, you know, there's no point in me grading that you can compile a program, right? So in that lab, you had like 1.2, 1.3. They're all really warm-up problems for 1.4. Okay, 1.4. So what I wanted you to do is to understand the mechanism of set UID. And I think some of you, from what I saw, most of you obviously get the idea that you create as root, a file, right? So you're a root, and then you create a file, and that file is called secret.txt. Only root can read this file, no one else, right? So all of you understood that. So if you do root cat secret.txt, you'll be able to read it, right? That's logical. If you're seed, but you do sudo cat secret txt, that's also, you'll be able to do it. That you know, because you're a sudoer. So really what you have to do is you have to do this. Cat secret.txt. But when you do this, it's going to say permission denied, right? It's going to say permission denied because it's not going to let you do it. So if you remember, I said, we talked about the effective ID and the real ID and all of that. So what I said is create a program in C. Right? You create a program. I don't even need all that room. Which most of you did the program. But you did some strange things in the program. So some of you wrote very complex code, and you really, I mean, you can solve it in many ways, I guess. But really, you just have to do something like this. Okay, that's about all you have to do in there. And so the idea is this program so the idea is this program is the same as this one, right? You cat. So that is clear. Now, when you are seed, now you've compiled it, you did everything. So now you do, oh, and let's give this a name. Let's call it myprog. Okay, so then you run myprog, right? You run myprog, and basically what you're doing is you're doing cat secret txt. But because you're seed, it still won't work. It's still going to be the same thing as before. It's going to give you permission denied. Okay, so that doesn't work. So now you are going to, and this question came up a couple of times in class, right? We have on, you know, when you're seed, you can do SH, right? And when you do SH, remember inside the system, SH is a symbolic link to bash. Bash is more secure. But if you change SH link from bash to CSH, right, the other program, then CSH has a vulnerability that allows you to retain the effective ID when you go from one process to another. So if you spawn a new process from an old process, CSH allows you to keep whatever you had, whatever effective ID you had in the old process, in the new spawn process, you also keep it. And that's the vulnerability. So bash does not have that. And so therefore bash will in this lab at least, it would not let you, bash would not let you do this. So you have to do CSH first of all. Remember, I gave two recommendations about CSH. Make sure that you never turn off the computer with SH pointing to CSH. Once you're done with the lab, link SH back to bash so that you don't have any problems. The other one was that you need to use in the lab itself, there's a few commands. It's like remove SH and then ln -s ... and it shows you that's the mechanism that you use to change these links, okay? So you break the link and then you, so anyway, so we've established already that CSH has a vulnerability. So this will work for this lab. That's what I wanted you to do. In the buffer overflow lab, we're going to learn, today I'm going to give you a few additional things to the buffer overflow lab but we're going to learn that we can actually bypass the whole CSH bash vulnerability. Or actually that we can, no, the fact that bash was preventing it in the set UID, in this one, we can bypass it. And I'll show you how. But anyway, for that lab, I just wanted to show you, okay, if there's a vulnerability, you know, we're exploiting. So how do you do it? Okay, we know that by running myprog, it doesn't work just out of the box, right? So you have to do two things. What are those things? You have to go in and you have to make myprog root owned. It has to be root owned and set UID. Right, so that means the owner of myprog has to be root. And when you do the permissions ls-l, myprog has to say, you know, in where you have read, write, execute should be an S for set UID, and the owner needs to be root. You understand that? So now the program is gonna run with, because it's set UID and root owned, it's going to run with the privileges of that program. So that's what you did with the chmod. Right, chmod 4755, I believe, myprog makes it set UID. Okay, and then once you do that, right, and once you have changed sh to point to csh, then you go into the prompt as seed, because I saw some of you, as I said, you were doing it with root, you were doing with sudo. In both of these, I didn't give you the points for them because it has to be seed. And then you go in here, and all you have to do, wherever the file is located, secret txt, you run myprog. Okay, myprog then will do system call. System call will call sh, right? And sh will call CSH because you've mapped it to CSH. If you've mapped it to CSH, then it has that vulnerability, okay? So it has that vulnerability. So the program myprog, when you call system, think of it as myprog is one context, right? Myprog is one context, but then you do the system call, and it's like you're, oops, it's like you're spawning a new one, right? For the system call, but the effective ID that you had here equal to root, which is 0, remains over here. And that's it. So when you do this, you should be able to read the secret. Shows secret. And that's it. That's literally the whole problem. I mean, it can be done in like, you know, less than 20 minutes, but I get it's confusing to understand. So you have to really understand this concept, and I want you to understand this concept, you know, as much as possible, right? So is this clear now, or are there, I mean, if you have questions, as I said, I want you to do it. I'm going to give you a second chance to do this lab for those of you that missed it, but I need to make sure that you understand what's going on. Is this clear, guys? Are there any questions?
Yeah, I've got it.
You got it now?
Yeah.
Okay. So I noticed that, like I said, a lot of you got some of it. Like you understand this part. Let me use a different color. So you understand this. You understand that part, and you understood this part. I think the part that may have been confusing was this one. The fact that you know, it sort of works with only CSH. It is only until the buffer overflow lab that we actually now bypass even that. But for that one, you just had to make it happen with CSH. And then the program has to be not just like that, but it has to be root owned, and that you have to make sure that it is set UID. So now seed runs the program, the effective ID is still roots. And when you make the system call inside, you spawn, right? You spawn a second process, but you retain the effective ID. Therefore, that cat is a root cat. And a root cat can read the secret file. And that's it. You should have shown the contents of it. Okay? So that's, again, I'm going to give you guys the opportunity to do this again. You will have to email me the assignment if you want me to consider it, and I have to see this correctly done, okay? So you will have to email it to me because I don't want to reopen the link. So email only. Or you can demo in class. Maybe you do it today. I mean, you know, if you fix it today, just demo it and I can update in the system. So that's set UID. Are there any questions about it? Is it clear? You know, Alicia said it was clear. How about the rest of you?
Yeah, it makes sense.
Okay, so I know some of you though got it right. So I know that, you know, some of you got it right already, but for those of you that maybe were a little bit confused, you know, just want to make sure now it is clear, right? So work on it now. I mean, if you got it wrong and you want additional points, work on it today, and I can help you out with it. But I'm telling you, it's pretty straightforward. It's just make sure, you know, that you understand that the most important concept here is about the fact that you are regular user, not a pseudo or not root, and you can still get the file because you're doing this. All right. All right. Anyway, I addressed that, so I believe that's hopefully addressed. Now let's move on to, I know I haven't looked at format string yet, but I believe that one is a little bit more straightforward. So hopefully you guys were able to do that one. Definitely ask questions today if you have them. Otherwise, as you can see, that we've been focusing most of our time on the buffer overflow. And what I assigned to you that I said by today, you should have gotten that root shell. You know how it says on the PDF, you know, root shell, and you type who am I. So I was working, I was helping some students last Thursday, and we were able to eventually get it to work. And I can't remember what their error was, but it was something even not related to the main idea. So you might have issues, but I can also take a look at that one if you would like. But you have to get root. So this has to say root, or I think it says 0 or something like that. If you just get the $, you know, you got a shell, but you didn't get a root shell. What's missing? It's probably you didn't understand set UID. Okay, so we definitely want to take a look at that. Now, for those of you that are finished, so kind of made it to here, you've made it there already. Okay, then let's see. Okay, so I'm getting some emails about set UID. Let me read through them. Root shell. Was me. Okay, yeah, so I think there's one way that some people did it. Okay, going back to set UID, I guess. So there's another way people sort of did this, and you have to convince me that this is correct, because what you did is you took CSH, you made it executable, and then when you get CSH, which must have been root owned and set UID, you get a shell, which is kind of, if you do who am I, you know, it's root. And then what some people did is they did cat, what was it, secret txt. And yes, this will give them, you know, the contents of it. The thing is, of those of you, I'm not saying it's wrong. You're not wrong. I'm just saying if this captures all the ideas from this approach. So of those of you that did this approach, would you like to defend it? Would you like to? So you did. Usually, I guess the idea would be that you wouldn't have access to CSH, but you would have access to a file, myprog, and then that file would take an input, and that's where you would come in and you would replace that input with your cat secret txt. So it's not wrong per se. I'm just debating if it's, if you I guess my point is, if you understand this, how you did this, right, this approach, do you also understand how this one works? Right? That's really what I need you to sort of convince me that you do. And if you do, then yes, you probably deserve full credit for this approach. Does that make sense?
Yeah, makes sense.
So feel free to defend it. I mean, I'm open to debating it. But do you get my point? I just want to make sure that you see it in the context of this one. So do you maybe want to walk through this one and just. It's similar, right? But
I think I got it, and I took a snip of this screen, so I'll have it for my notes again.
yeah, so you can submit again. Submit this one if you'd like. I have no. I mean, like I said, you'll have to email it, but just I want to see that. I would rather see this over this. If you want to stick with this one, just you know, make a convincing argument that this one addresses everything. Like, how would you use it in the context of of reading the file? Make sense?
Yes.
Okay. All right. So yeah, either one. Yeah, I would strongly recommend just this one because it's more captures more the ideas, but you can also try that. It's fine. Just the thing is, you know, you probably would not have access to CSH. You can link it, but you can't just like, because the problem is, as I said, in the future, as you've seen in the buffer overflow lab, we would be exploiting this, which would be a user control input, and we're doing a code injection, right? A code injection. Here, because it was the first lab, I just made it pretty straightforward by letting you guys kind of hard code that in there. And the problem with this one is, yeah, by doing this, you get a root shell, but you know, you can do anything then. So I would say the other one's a little bit more correct. But you know, I'm always open for debate. So if you want to talk now or maybe contact me later via email or during office hours, that's fine. All right. But great point. Are there any other comments or questions about set UID? And given that you're going to do this on the practical and the written exam, I would probably recommend that you make sure that you know how to do this one. Okay? All right. I don't hear any questions. So I guess I'm going to go back to what I was saying here, right? Buffer overflow. Let me just create a new slide so it's cleaner. Right, so buffer overflow. All right. So here, remember in buffer overflow, hopefully by now you have gotten to getting a root shell. Who am I? Your root. But you did all of this with CSH, just like with the format string, or sorry, just like with the set UID lab. Now we need to move to the next part. So let me share the PDF. All right, so I'm going to share the PDF here. Okay. All right, so you should be seeing the PDF there, and you did that shell code. So you should, the first thing you should do is run this shell code. Make sure it works. So hopefully all of you have done that. Then definitely run this one because this is the actual code that you will be injecting, if you remember. And so you want to make sure you can get that to work. You got your little programs there. And when you do the first task, you should get this. So this is where hopefully, I expect that hopefully by now, all of you got this one, the root shell with CSH. All right, now you're gonna switch over, and here's kind of the explanation of what I said. So now the problem is gonna get a little bit more complex because now we're gonna change that SH link, if you notice, back to bash. So we're gonna go back to bash. And as you know from the set UID lab, bash has a security mechanism. So it doesn't allow you to retain the effective ID. So how do you bypass that? Okay, you have to think about it. So bash will take away your effective ID of root, unfortunately. So what can you do? Well, in programming, if you were writing a C program, you could just go back to being root simply by typing in this. You see, that makes gives you root access basically. So many commands will behave differently if they are executed in set UID processes instead of just as root processes, because they recognize the real user ID is not root. To solve this problem, you can run the following program to turn the real user ID to root. This way you will have a root process. So basically what this is saying is that these are the commands in C to change your effective ID basically to root. So you're gonna like explicitly do it now. And so then it's pretty simple. For this, once you've succeeded in the previous one, the next two problems are super easy. All you have to do is what you did in the set UID lab, do the whole remove the link, create a new symbolic link. Now you're gonna point to bash, run it, it'll fail, right? When you run stack now, it'll fail because, you know, bash has a mechanism. So what you have to do is you have to go in, you only have to do one little thing. If you remember, this is the shell code, right? So this is the shell code. So if you think about it, this shell code executes and it runs the shell. But here it's saying, before you run the shell, which is this, so basically this, you can think of it as being this. Well, they're giving you the solution. So if you want to bypass bash, before you run this, okay? So what that simply means is that we need to add a few more commands to the shell code, right? So but we can't add them in C, unfortunately. We have to add them in machine code. So what we're going to end up doing is that before these, right, before this X31, we're going to, like, in here where, I don't know if you can see my cursor, and my pen doesn't work on this, but like where I'm like trying to write there, you're going to insert a few more machine code commands. And those machine code commands will be the equivalent of this. So therefore, just before you run the shell, you also make yourself root. So at that point, it doesn't matter if you have bash, dash, CSH, you bypass that security. Does that make sense, guys? Was that clear?
Yeah.
Okay, great. All right, so I'm glad it's clear. So what I'm going to do now is I'm not going to ask you, you know, to create machine code. I'm just going to give you the equivalent of that, and then you just have to add it in. Okay, that's all I'm going to do. And as I said, these are easy. Once you've figured out the other part, that finding the return address, really, the rest is super easy. So now I'm going to go here, and I'm going to give you that command. Okay, so basically your shell code looks like this currently. It looks like shell code, right? And then I'm just going to assume that I pressed enter several times, right? And then you have your X31. Oops. So you have your X31, X C0, and X50. Right, and so on, okay? So what you need to do here is you need to write the shell code that goes in that spot. Or sorry, yeah, the set UID command. All right, so in the PDF here, that would basically you know, what I showed you, the hex equivalent of that is all you have to do to modify it. All right, now once you complete that, we're going to go to address randomization. With address randomization, all you have to do is, again, repeat everything, but this time you're going to go into the system and re-enable address randomization. So whereas before you had a 0 here, right, to turn it off, now you're going to turn it back on. So the return address that you had would be different, right? In theory, the return address would be different, but here you have the solution is provided for you. All you have to do is run this. And this is equivalent to running a brute force attack. So you're just going to run stack with the return address that you have, but you run it thousands of times, because if you notice here, the while loop is an infinite loop while true. So you're just running stack over and 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 over, right? Every time the stack is initialized to a different randomized address space. But eventually, what's going to happen is it's going to use the address space that existed when you did the analysis, and boom, you're going to succeed. Why is that? Because computers are deterministic, right? So in a, the space of a password, the actual space of a password is, very, very large, very large. So doing a dictionary attack on a password still is harder to work. But on a computer, and hopefully you can see the screen, the whiteboard, on a computer, memory is much, much smaller. It's not infinite, right? And so the fact is the computer is very deterministic. Eventually, I'm just going to do some drawings here, but maybe it allocates the memory like that, the next iteration over here, the next iteration over here, then over here. But eventually it goes back to that, so it's deterministic. So all you have to do really is run it multiple times, and eventually you should succeed in getting your root shell. And that's it. That's the whole lab. The last problem is just to turn on everything. And then once you turn on everything, yes, stack smashing will not let you succeed. But, the whole point of the lab is to kind of explore all the mechanisms and to get an intuition of how things work. And that's it. That's your whole lab for buffer overflow. As I said, it's very important that you don't just do it once, right? You gotta really do this a couple of times, few times, understand it, because as I said, when I give you the practical exam, I do a slightly different buffer overflow. And what I want you to do is understand how to solve it. So what I like to do now is I'm going to talk about buffer overflow 2, where buffer overflow 2 is the practical exam. But before I talk about it, are there any questions about buffer overflow 1? So I have at this point discussed the entire lab. And so is there anything that's unclear or?
I had a quick question.
Please.
Last week you told us to use the updated version, but you were looking at the older version of the buffer overflow. So are we supposed to combine the commands from those, or?
They're both identical, almost identical, Alicia. I believe they're almost identical. Are there many differences that you encountered in them?
There's a few. There's some extra instructions that would have been helpful. I was working off of the 2021.
Yeah, definitely read both. But I believe they're almost the same. So that's why I put them there, so that you read them. There's almost no, same shell code. Are you seeing this, or are you still seeing the board?
I'm seeing the whiteboard.
Okay, let me switch to this. All right, so I'm going over that one. Pretty much, we're doing all this. How to disable randomization, FNO stack protector, XX stack, BNSH, all that is in there. How to break the link, running the shell codes, same thing. That's the same. Vulnerable program, I don't see any difference. Pretty much the same. I think I gave you the code for exploits, right? So I believe I gave you that. Here it is. All right. I gave all of this to you guys, right? The 2 for loops, right? I talked about the NOV-SLED, then I talked about how to copy the return address. I think I gave you these. If I haven't, let me know and I'll give them to you again. Then this, I just talked about this just now, so it's the exact same thing. This one is in Python. So this one, but that's the same thing, just creating the same file in Python. You guys are Python experts, right? So I'm sure you can write that code, or just use the C version I gave you. Then you just have to do what I said for defeating bash. You don't have to do this part. What else? Address randomization. This just calculates how long it took. I mean, it's the same. Yeah, so I think they're pretty consistent. You really just have to do the tasks, those tasks that are requested. I think that should be enough. All right, are there any other questions?
Yeah, I have a question. For 2.2 for that lab buffer overflow, I seems to run into a problem of segmentation fault for
Where?
some reason, and I copied the code directly from the website.
Yep. 2.4.
2.2, sorry.
2.2.
That's all the way up. Yeah,
Oh, just running the shell code, you mean?
just running the shell. I'm
But
experiencing
you
some
are
issues.
running this one, and which one of these two are you having problems with?
I'm running the assembly version.
This one.
Yes.
So just to note what you said, the assembly version, actually assembly is this part. So it's the machine code.
Oh, machine. Yeah.
You know what I mean? So the assembly shown there is actually just comments. Just be aware of that. Okay, so this program should run. Basically, all it does is it calls, it makes a string copy here, and then it runs buff. And buff then runs this, which basically means it runs a shell. So you should get a little prompt like the dollar sign, for instance.
Yeah, it should be the dollar symbol, but I kept getting like the segmentation fault for some reason, and I'm just like, I'm not sure why I'm getting that.
So why are you getting a segmentation fault? If you're getting a segmentation fault, it's possible that it tried to read an address that was pointing to gibberish. So that would probably mean, as the CPU is reading instructions, there might be something wrong in your. So one recommendation I would give is just type this part.
Okay.
Yeah, you don't have to include the assembly part, just type this. If you copied this from a PDF, check the double quotes, because I think sometimes double quotes in PDFs are a little bit different than double quotes in
Okay, I'll try that.
in the actual double quotes in the C language. Here,
Okay,
even
thank you.
if you copy it, there wouldn't be any errors. But remember that whatever you put here in memory, it's going to try to interpret. The CPU literally tries to interpret things. And if you have weird characters in there, it's gonna error out. So I would think it's probably this, somewhere in there. Maybe just copy it and that'll solve it for you. Or sorry, type it.
Yeah, I'll do that.
All right, great.
Thank you.
Great question. All right, any other questions?
Not right now.
Nope. All right, so that was clear. All right, good. So where are we? Oh, yeah. So we've addressed the lab, buffer overflow, and the rest of the time today, I'm just going to keep it as an open lab for you guys to ask questions. But I do like to give you a little bit of a heads up on the quiz or the practical exam. Okay. So let me switch back to the whiteboard. All right, here we are. So let's call this buffer overflow 2. All right. So one thing that's going to be different about buffer overflow 2 is that in buffer overflow 1, you read the code injection, the code was in a file, right? In bad file, right? So that's, you created that exploit and then you created the buffer and you put all that contents in bad file. In buffer overflow 2, I'm going to ask you to create the code injection on the terminal. That's going to be different because you're going to have to craft it in there. Obviously, that's going to be smaller. Now, a couple of things that are important. When you run, you're going to use GDB on that one as well. So you're going to use GDB. And you're going to, you know, hit like breakpoint something, let's say 26, and then GDB run, right? And you're going to look at things. When you let it run, you're going to get an error, SIGSAG-V, right? And that error shows you what it read in the return address. So usually, like if you, for instance, if you only injected NOPs into the buffer of buffer overflow 1, you would see a bunch of 90s here because you had a bunch of 90s overwrite the return address. I would strongly recommend that you do that as practice for buffer overflow 2. Make that buffer from buffer overflow 1 just NOPs. Don't even include like the return address or the exploit. Just do that. Let it run to SIGSAG-V, the error you get, and make sure that it says where I was supposed to read the return address, I read a whole bunch of NOPs. Okay? That's the first thing. Then imagine if you, in the terminal, you were doing this, you would again do not 90s, right? You do a whole bunch of 90s, ... And that's how you would end up with the same problem, except that it might be better to do A, B, C, D, E, F, G, H, I, you know, all of these, and then maybe even backwards, right? So C, X, you know, and then 1, 2, 3, and then backwards, right? So all of these characters, it's a useful strategy to do this to figure out where the return address should go. Why? Because 4 of these letters are going to overwrite the return address. So for instance, when you do that instead of NOPs, and you let the program run again in GDB, and you get a SIGSAG-V, what's going to happen? You're going to get EFGH. You're going to see that in there, right? And when you see that in there, what does that tell you? What does that tell you? Here. What is the meaning that you saw EFG there and EFG here? What is the meaning of that?
Does it mean that you have over the address?
Exactly. You know where the return address is in memory. So by knowing this, now you know where to put your return address. Does that make sense?
Yes.
Okay, now the trick is that unfortunately, they're not going to be the letters, right? They're going to be the hex equivalent of the letters. So make sure you have the ASCII table with you, right? Because you're going to have to insert the ASCII characters instead of the letters themselves. Also, remember that things are inverted. But that won't matter because, you know, whether you see H, G, F, E, or E, F, G, it doesn't matter. You understand that, okay, there's a pattern there. So that's not such a big one. With the ASCII characters, kind of practice knowing what each character is in relation to the equivalent number, decimal and hex. Okay, so that's the first thing that I want you to kind of be aware of, that that's how I'm going to do it. I will give you a few functions in Perl or Python that will make your life a lot easier, so don't worry about that. My only interest is that you understand this concept, okay? The second concept that I want you to be aware of is that I may take one of two approaches. I may say, inject the shell, or I may put the shell 1 or 2. So one is inject. So you'd have to inject it somehow through there, right? Or I may actually put the shell in memory already. So it's in memory already, but you still, for both scenarios, whether you inject it or it's already in memory, you still need to find the return address, right? And to find that return address, remember, you gotta use GDB. Okay, so just like you found a return address for this buffer overflow lab, you gotta find the return address for the practical exam. Is that clear, guys?
Yes.
Okay, great. This will be probably, you know, these two things are the main parts of the test, right? That one, and then finding the return address. And it could be, maybe I don't even want to do a shell. Maybe I just want to do some other function, you know, just print, you know, something like, ooh, you got this quiz, something like that. But it's all going to be on the Ubuntu, so you're going to need your seed VM. Make sure you have a seed VM working that day. And I will give you the code. So that's the one thing that I will provide the C code on the day of the exam. It'll be there on the Brightspace, okay? And that's it. This is buffer overflow. It's just another way of viewing the same problem. I may tweak it here and there, but it'll be something like this. So remember the commands in GDB, right? Have a cheat sheet of all the commands that we learned, right? So you had, you know, disassemble, you know, and you have all the ones I mentioned over here. I also showed you how to, you know, the P, $EBP, right? EBP, remember that you can always do operations in GDB. So if you want to find an address, you can always do P, EBP, or one of those plus 20, right? And that just gives you the address with an offset of 20 bytes, for instance. So that, you know, that might be helpful. Okay, so I might use a knob sled, or maybe I won't. I still haven't decided which way I'm going to go, but I may make it easy. Okay, if you want to find the address of a specific function, let's say that you have function 1, right? You have function 1, function 2, function 3, and I want you to jump to that function. If you want to find the address of that function, you just can do disassemble function 1, and then it shows you the function and it shows you all the addresses. I mean, you know, so that's another thing that I could do. I may require you to make it set UID and get a root shell, or I may just say, you know what, I don't even need a root shell, or I may, as I said, just ask you to jump to some other program. It could be many things. All right. So do you guys think you'll be ready to take this practical exam called Buffer Overflow 2 a week from today on Thursday?
Not really.
Huh? Not really? Okay. When do
I don't think I'll be confident in it. No.
Okay, so 2 weeks from now then?
That would be great.
Yes, that'll help a lot.
Okay. All right, let's do that then. The written exam next week. There's a question there. All right, good. So 2 weeks then. So but like I said, today's the last day that I can dedicate to buffer overflow, right? So I've gone over it several times. If you're struggling, you need to get in touch with me to finish it, given that it is very important that you do well on that practical. And then, yeah, so today let's finish up the lab. Any questions you have? I think at this point I've given you all the new material. So I'll probably pause the video in a second, and then we can just do an open lab. And then Tuesday, written exam, just like a standard exam 1. Thursday, that means I have to start a new topic. So what I will do is either give you time to start working on the term project, your web security, because remember, once we are done with these 2 tests, we're moving into web security. So that means pretty much all of this, code injections, input validation, but no longer in C++. Now we're going to move to the web languages, which are more like JavaScript, SQL, PHP, and so on. And then the practical exam, then it's going to be scheduled for 2 weeks from today. All right, let's agree on that. All right, that sounds good. All right, so now I'm going to go ahead and pause the. All right, guys, so don't forget the exam is on Tuesday. Keep working on your lab. Let me know if you have any questions. We're going to stop here for today, and I'll see you next week. Have a good weekend.